In streaming replication, replica is compelled to retrieve every aspect of original server, including database, tables, roles, and more. However, what if our intention is to replicate only specific table? This is prescriptively where logical replication takes center stage. With logical replication, we have the flexibility to select only a subset of tables for replication. Here, Postgres need to perform a logical decoding of the records from the WL file and generate a series of SQL statements. Subsequently, the real statements are transmitted via the network to the standby server. In the end, the statements are enforced on the standby server's tables, maintaining the accurate transactional order. In logical replication, we work with two key components, a publisher and a subscriber. A publisher, essentially a node, represents a specific set of tables referred to as publication. To receive updates from this particular group of tables, a subscriber can opt in by establishing a subscription. One significant advantage of logical replication is approach to data transfer. In streaming replication, every change made to the master server must be transferred regardless of whether it alters the actual data. This can impose a heavy burden on the network and become a bottleneck for systems experiencing high loads. Unlike streaming replication, where every modification is transmitted, logical replication provides the flexibility to execute only the necessary commands on the replica. Logical replication lacks support for certain ideal commands like creating indexes. We can perform these operations independently on the replica. In this case, the amount of data sent over the network will be much smaller. Moreover, for physical data replication to function effectively, it mandates an exact configuration match between the synchronized servers. We don't operate with traditional master standby setup. Instead, we have publisher and subscriber. This approach grants us greater flexibility and enables us to configure multiple architecture tailored to our specific requirements. Let's dive into the practical demonstration of how logical replication functions. For this demonstration, I will be using two PostgreSQL servers running on two virtual boxes. In the initial phase, we will establish the environment and in subsequent phase, we will configure and test the replication. Before initializing the cluster, we first create the record folders on respective servers. Now, before initializing, let's check the IP addresses of the servers also. Initially, I plan to establish a database cluster for the publisher using initdb. The process of setting up a new cluster encompasses the creation of the necessary directories for housing the database, the generation of system tables, and the establishment of default database named Postgres. Okay, now we build another database cluster for the subscriber, the second server. So now we switch over to the directory in which we initialize the database cluster. Prior to initiating the instance for both publisher and subscriber, it is important that we make some adjustments to PostgreSQL configuration file. First, we will change the listening address from localhost to star so that it can listen to all addresses, so all IP addresses. Next, we can change the port. I have running some other instances also, so I am changing the port to 5436. And another one important settings, what we want to do is we want to change the level, wall level. For that, we can search that wall level and change the wall level to logical. So this directive will instruct the server to include supplementary data into WAL log, thereby enabling the replication. Another one important config change we need to do before starting the server is we want to add the IP addresses of the remote servers in the pg underscore HBA file. So for that, I am including that IP addresses here. So this IP address is belong to the subscriber, so that which we have, once we added this IP address, the subscriber can connect. So now everything is good for us to start the server. So let's start the server. To starting the server, we can use the pg underscore ctl command. Here we can add the log file also, especially for starting startup logs. I plan to use that. For that, we can use the -l parameter following with the file name, log file name, and the start signal. Okay, now the server started. Okay, now we are good to start services in the secondary server as well. In the secondary server, we don't need to change the wall level. So just we need to change the listener address and the port in the PostgreSQL configuration file. Listener address to start so that you can listen to all IP addresses. The port to 5436, as I have some other instructions running in 5432, and command the port. Okay, control O, right out, and control X to exit. Now the same thing we done for the primary in the pg underscore HBA file. Here we need to add the primary address here, primary address, so that the primary can connect to the secondary. Okay, both changes are done. Now we are good to start the services or server in the secondary as well. Okay, the server started in the secondary also. Next, we can connect to these instances by using the PSQL command and the port number, so that it will connect to the default database Postgres. Okay, now both the instances are ready. Now we connect to the publisher and create a database. Publisher. Okay, database created. Now we can create a symbol table by connecting to that publisher database. Create table list of ID integer and make it as a primary key. And next field as name, spare car. Okay, the table created. Now insert some dummy values into the table for testing purpose. Generate underscore series of 1 comma some 10 values. Okay, and next can name single quotes and the pipe single and generate the same series of 1 to 10. Okay, the value got inserted. Now for checking purpose, we select the values. Select start from list. These entries represent the newly added records in the table. As logical replication does not support for this scenario, we will need to execute equivalent commands on the subscriber server to achieve the same outcome. Alternatively, to replicate the schema itself, we can employ the pg underscore dump command. So pg underscore dump minus t list the table name, minus s the database name publisher, and minus p the port 5436. Here we need to transfer this backup to subscriber server to get the identical schema on the subscriber server. So rather than manually copying and pasting these details to another machine, we can simply pipe the result. PSQL minus h the host such that the subscriber IP address, minus p the port address of the subscriber, minus s the subscriber is a database which must exist in the subscriber server. Hey, yeah, we create the subscriber database in the subscriber server first. Yeah, database created. Now we run the same command. Okay, the schemas must be transferred to the subscriber server. Let's check that. Let's connect to the subscriber database slash d. Yeah, the schema is there now. For testing, we will select from that list. Okay. Now both servers are ready. We can create subscription and publication. For that, first we will connect to our publication publisher database. Now create publication and any name. I am giving my pub for table list. So here I am creating for one table. We can create for all tables also if we need it. Now we can create the subscription. For that we move to the subscription server and create subscription, my sub. Any name you can give that. I am giving my sub. And followed by connection and single quotes we want to give a DB name equal to publisher. Here we want to give the publisher DB name from the publication server and the host equal to the publisher host address here. And now the port details, port 5436. Okay, now the user Postgres. The user must have the connection access to that host, and the publication name, publication mypub. Cross check everything. Okay, I missed the semicolon. Yeah, the subscription created. Now must be the data will be replicated from the publisher to the subscription. Let's check that. Select star from list. Okay, the data got migrated. The replication is working fine as expected. Now check the replication by performing some updates, update delete operations in the publisher. Let's connect to the publisher database. Okay, sorry. Now update on record from the list table. Updating the name to some Postgres where id equal to okay 10. Okay, updated. Let's check on the subscription server now whether it's migrated there or not. Okay, it's working as expected. Now delete on record from the publication server. Okay, delete also performed. Let's select that from the subscription. Yeah. So everything working as expected.